These are notes for section 9.5. Okay, 9.5 here. So page 539, 1 to 43 odd. We're solving equations with radicals now. And we have to go up to 43. So let's see, there's 43 there. And the answer is in the back of the book, 9.5. Let's see, up to 43. Yeah, and I think it's all there. All right, one thing about these problems is they always have to be checked, whether the question says so or not. Sometimes the problem just doesn't work in the process of solving these. Okay, square root of 2x plus 1 equals 3. The normal thing we're going to do is to square both sides. If there's a cube root, we would cube both sides. So square both sides, that takes off the square root. 2x plus 1 equals 9. Subtract 1, 2x equals 8, x equals 4. But you must always check your answers. Sometimes it'll check, sometimes it won't. Plug back in 4. 2 times 4 plus 1, is that equal to 3? Question mark means we're checking to see if it is. And the square root of 9 is equal to 3, so it does check. Okay, however, let's take a look at number 3. Square root of 4x plus 1 equals negative 5. So you square both sides, because when you square a square root, it just takes off the square root. 4x plus 1 equals negative 5 squared is 25. Subtract 1, divide by 4x equals 6, but it does not check. If you plug in 6 here, 4 times 6 plus 1 is 25. The square root of 25 is not negative 5. So we actually have no solution. So if you didn't bother to check, you would have left your answer as x equals 6, and that's incorrect. So no solution. Okay, 11. Square root of 4a plus 1 plus 3 equals 2. Get rid of the 3, subtract 3. Square root of 4a plus 1 is negative 1. Square both sides. 4a plus 1 equals 1. Subtract 1. 4a equals 0. Divide by 4. A equals 0. However, again, does not check. If you put a 0 in here, square root of 4 times 0 plus 1 plus 3, is that equal to 2? Well, this comes out to be 1. 1 plus 3 is certainly not equal to 2. No solution. Okay, so for these examples, if there's a square root, you square both sides. Now, what if you have a cube root? You cube both sides. So in this one, raise both sides to the third power, cube it. Because if you cube a cube root, that's what cleans this up. So 3a plus 5 equals negative 3 cubed is negative 27. Subtract 5, 3a equals negative 32. Divide by 3, a is negative 32 over 3. Does that check? Plug back into the original. 3 times negative 32 over 3, well, the 3's cancel out. You have negative 32 plus 5, which is negative 27. The cube root of negative 27 is indeed negative 3, so it does check. What if you have a fourth root? You raise both sides to the fourth power. Whatever the index here, raise it to that power. Although most of the problems are going to be square roots. They give you a few other ones, but usually square root. So raise both sides to the fourth power. 3x plus 1, 2 to the fourth is 16. Subtract 1, 3x is 15. Divide by 3, x equals 5. Double check, plug in 5 right here. 3 times 5 plus 1 is 16. Fourth root of 16 is indeed 2, so that works. Okay, 19, square root of y minus 3 equals y minus 3. Square both sides. So the left side is simply y minus 3. This one you got to square. Y squared minus 6y plus 9. This is a quadratic equation, means put everything on one side equal to 0. Subtract y on both sides. Add 3 to both sides. So if I subtract y, I have y squared minus 7y. Add 3 plus 12. Factor y minus 4 and y minus 3. So y is either 4 or 3. They should both be checked back in the original. Plug in 4. Square root of 4 minus 3 equals 4 minus 3. Square root of 1 equals 1. That checks. Plug in 3 back in the original. Square root of 3 minus 3 equals 3 minus 3. Square root of 0 equals 0. That also checks. 27 is actually easier than you might think. Both sides have a fourth root, so you raise both sides to the fourth power, take off the radicals, and you just have simply 5x minus 8 equals 4x minus 1. Okay, subtract 4x on both sides. X minus 8 is -1. Add 8, x equals 7. Double check. Plug in 7 here and here. Square root of 5 times 7 minus 8. Fourth root rather. Fourth root of 4 times 7 minus 1. 5 times 7 is 35. Minus 8 is 27. 4 times 8 is 28. Minus 1 is 27. The fourth root of 27 is equal to the fourth root of 27. Okay, 31. When it's like this, square both sides. It's actually easier to square the right-hand side. Just take up the square root. This one's a little harder. Use the shortcut formula. A squared plus 2ab plus b squared is how you square that. So t squared plus 10t plus 25 equals 2t plus 9. Subtract 2t on both sides. Subtract 9 on both sides, so that way you get a 0. T squared plus 8t plus 16 equals 0. This factors in a t plus 4 quantity squared equals 0. So what number makes this 0? -4. But check it. Check by plugging in -4 back to the original, right here and right here. -4 plus 5, is that equal to square root of 2 times -4 plus 9? That should be a question mark right there. 1 is equal to the square root of 1, so that checks. Okay, finally 37 is an example where you have to square twice. That's just the way it goes. So square both sides. This is nice. X minus 8. This one, it's a squared minus 2ab plus b squared, the shortcut. So I square this, x, minus 2ab, 2 times that is minus 4 radical x plus 4. Subtract x on both sides, it's gone. Subtract 4 on both sides, -12 equals -4 radical x. Divide both sides by -4. 3 equals radical x. Square both sides. 9 equals x, or x equals 9. Okay. Check, plug back into the original. Plug in 9 right here, 9 right here. Square root of 9 minus 8, is that equal to square root of 9 minus 2? 9 minus 8 is 1, square root of 1 is 1. And this comes out to be 3 minus 2, so it does indeed check. Right, so these are notes for section 9.5.